Okay, I wanted to do a video here summarizing some divisibility rules. Divisibility rules come up pretty frequently in math, not just when we're talking about least common multiples or greatest common factors. I use it even when I'm doing like construction work. If I want to know if I got a 3-inch wide board and I'm spacing them across the room, I can measure the length of the room or the width of the room and see if the boards will fit evenly across the room. And things like that. So I see divisibility rules pop up all the time in math. It's just nice to know if I've got a large number, what numbers will go into it. And I got to say that the most common ones I see out of all of these that you've got listed here, they'll go all the way up to 12. I use 2 a lot, 3, 5, 6, and 10. Those are my most common ones, but I think it's pretty cool to learn new ones, so I went ahead and included 2 through 12 here. And so I've got some numbers on the right, and then we're going to check 2 through 12 and see which ones will go into it without actually dividing the number out. So the first rule is for 2, if the last digit is pretty much even. That's what they're saying there, 0, 2, 4, 6, or 8. So when I'm looking at this, the last digit right here is 5. It's not an even number. It's not going to be divisible by 2. And so as we go through and look at these, this will work. So 2 works there. Let me try to make a better circle around the 2. In fact, I'll just leave it and highlight it here in a moment. 154 is even. That works. 1 is odd, so 2 will not work there. The 0 being in the ones digit there will make that number divisible by 2. And then 6 there works as well. So in all of these, we can go ahead and highlight those. The 2 does work. The next one I said I use a ton. Like I said, I really did use it for flooring because I had 3-inch wide boards, and I was working on one side of the house, and I wanted to make sure that as they came across to where the stairs were, I didn't have to cut like a sliver of a board to meet the stairs. I wanted them to meet there perfectly. And I could use this rule right here to see if the length or the width of my room would work there. So basically you add up all the digits, and if the sum is divisible by 3, the number is also divisible by 3. So for instance, our first example here, 3, 2, 4, 5, add up 3 plus 2 plus 4 plus 5. I'm going to do that. I get 3 plus 2 is 5. 5 and 5 make 10 plus 4 gives me 14. And 3 will not divide into 14. So that tells me that 3,245 cannot be divided by 3. Some things I like to do sometimes, I'll give my students a number like this and say, now give me a number that is divisible by 3. And that's what I've done here when I came up with these two numbers. The first one I knew was not divisible by 3, but if I just added one more unit to really any of these numbers, then their sum becomes 15. Like right here, I added 1 to the ones place there, and I get 15. And 3 will divide into 15, so that means the 3 is going to work here. So going to the next one, we got 154. Adding these up, 1 plus 5 plus 4 is 10. 3 will not go into 10, so 3 does not divide 154. 161, adding those digits up, I get an 8. 3 will not go into 8, so 3 is out there. 1, 8, and 7 plus 0 add up to 16. 3 will not go into 16, so 3 is out here. And then 4, 7, and 6 add up to 17, and 3 is going to be out right here. So we only have one number that's going to be divisible by 3 in this example. Let's go ahead and highlight that one. And I'll erase this other work off of here. Now I'm going to jump around here while we've got this going on, and I'm going to jump down to 6. We've covered 2 and we've covered 3. Let's look at 6 now, because those are very common ones that I use. So 6 says if a number is divisible by 2 and 3, then it's also divisible by 6. So I already know, since I've got 2 and 3 checked out here, that that's not divisible by 6. These right here are divisible by 2, these 3, but they're not divisible by 3, so that means 6 is ruled out as well for all of these in here where both 2 and 3 are not available. This one, however, 2 and 3 will go into 3,246, so will 6. The next thing that is pretty common for me to use is 5. So if the last digit is a 0 or 5, 5 will work. So here we have a 5, I know 5 is going to work. And here we have a 0, so I know 5 will work here. Everywhere else, 5 will not work. And I think that's one that almost everybody knows off the top of their head. But sometimes, people need to be reminded, so I'm just reminding you in case you didn't know. And let's go ahead and highlight the ones that it does work with. Let's see, here and here. And so another common one is the 10. Let's look at the 10. If the last digit is 0. Well, there's only one right here that the last digit is 0, and so this is the only number on here that's divisible by 10. And so all these others, the 10 gets marked off on. Going ahead now and looking at the 4, it says if the last 2 digits is divisible by 4, then the number is divisible by 4. So when we say the last 2 digits, we're talking about these right here. So 4 will not go into 45 because I know it goes into 44. So 4 doesn't work there. Same thing here, it will not go into 46. It will not go into 54 because, let's see, what's something we know close to it? We know that 4 times 12 is 48, so 4 times 13 is 52. So it's just 2 away from going into that. Let's see, for 61, I know that 4 times 15 is 60, so it won't go into 61, so it's 161 is out. Once again, 4 times 15 is 60, so you're 10 away from 70, so that's not going to work either. 4 won't go into 70, but 4 will go into 76. So the way I think about that is, I don't have that memorized, but I do know that 4 times 15 equals 60. And so if I subtract 60 from 17, I get 16. And I know that 4 will go into 16. So 4 times 15 gives me 60. 4 times 4 gives me 16. So it's going to be 15 plus 4, or 19 times 4 will give me 76. You could also look at it, that was the first thing that came to my head. An easier way, I guess, to think about it is that 4 times what gives you 80? 4 times 20 will give you 80. So if you go one less than that, 4 times 19, you get 76 there. So that means 4 will go into 476. So we do have one on here divisible by 4. Now, I'm going to go ahead and jump down to 12, our rule for 12, which you can't see on the screen. It says if a number is divisible by 3 and 4. So the only number we had divisible by 4 was 476, which is not divisible by 3. So none of these numbers I have up here are divisible by 12. Now, the 7 is not used very often, this divisibility rule for 7. It's actually kind of a strange one. In fact, sometimes I see, when I look up these divisibility rule charts, 7's not even included. They say there is no rule, but there is a rule. So, whoops, didn't mean to erase that. It says cross off the last digit and double it, and then subtract it from the remaining digits, and if that's divisible by 7, then so is your number. So it seems a little strange to do. I'm going to start down with these smaller digits so you kind of get the idea first before we move on to the larger digits. So cross off the last digit. So in this case, we're going to cross off the 4. Now double 4, you get 8, and subtract it from that, and you get 7. Will 7 go into 7? Yes, it will. So this one right here works for 7. Try it with this one. Cross off the last one, 1. Double 1, you get 2. Subtract it from 16, you get a 14. Will 7 go into 14? It will. So 7 will go into 161. If we get a larger number, like a 4-digit number here, let's look at the last digit, cross it off, double it. 2 times 0 is 0. Subtract it. Will 7 go into 187? I don't know. Let's do the process again. So cross off the last digit, 7. Double it, you get 14. Subtract, you get 4. and 7 will not go into 4, so I know 7 will not go into 1,870. Let's look at this one. Cross off the last digit, double it, and subtract. I get 35. Will 7 go into 35? It will. So I know that 7 will go into 476. And if you want, you can pause the video, try these two up here at the top, and see if 7 will divide those. Take the 5, cross it off, double it, and subtract. We get 314. Kind of run out of room right there, so I'm going to write it right here, 314. Let's see if that 7 will go into that number. Cross off the last digit, double it, and subtract. And I'm going to get, what, 22 plus 1, or 23. 7 will not go into 23, so 7 will not go into our original number. We got one more to cover here. Circle your last digit, cross it off, double it, and subtract. You get 312. Now I don't know if 312 is divisible by 7 off the top of my head, so I'm going to repeat the process. Cross off the last digit, double it, subtract, and I'm going to get 27. 7 will not go into 27, so 7 will not go into 3,246. So I had two numbers here that 7 will go into. Let's highlight those. And we got three more numbers to look at. Let's look at 8. 8 works if the last three digits are divisible by 8. So we had one like that already. Look at 4. If the last two digits were divisible by 4. So for the 8s, the last three digits have to be divisible by 8 for that to work. So if the last three digits are divisible by 8, let's look at this one right here. 245, is that divisible by 8? So in my head, I just think, if this were an 8 and dividing into it, 8 goes into 24 3 times, so you subtract 5. 8 does not go into 5, so the larger number is not divisible by 8. Now, I don't really like to write out and try to long divide these things, but I just want to show you what I'm thinking mentally as I look at this. I say 8 goes into 24 evenly, it won't go into 5 evenly, so you're stuck there. Now, if it were 3,248, then 8 would go into it because 8 goes into 248 evenly, 31 times. Same rule for this second line right here. It's not going to work because 8 will go into 24, but not 246. Now, when you get down to a three-digit number, this rule for 8 is not quite helpful because you got to divide it out to see if it's divisible by that. I know that if you're thinking about dividing that, 8 goes in there once, subtract the 8, you get 74. 8 won't go into 74, so it won't go into 154. But at that point, you're almost dividing it all out anyway. Same thing right here. I know that 8 will go into 16 twice. Subtract, and you're going to get 1/8 left over, or 1 over 8. So 8 will not go into either one of those numbers. Like I said, 8's not a common one that we use, but there's still a rule for it, so that's why I'm covering it. 870, I know that 8 will go into 800 100 times. Will 8 go into 70? Well, I know 8 goes into 80 evenly 10 times, but 8 times 9 is 72. 8's not going to go into 70, so 8 won't go into 1870. Let's look at 476. Once again, this is a three-digit number, so it's not that helpful. I know that 8's going to go in here 5 times. I'm left over with 76. 8 won't go into 76, so none of these are divisible by 8. All right, and then for 9, if the sum of the digits is divisible by 9, then we can say the number is divisible by 9. So if you think about it, any number divisible by 9 is also divisible by 3. So none of these that were not divisible by 3 are going to work. So 3 plus 2 is 5, plus 5 and 4 gives you 14 again. 9 won't go into 14. This one's going to add up to 15. 9 won't go into 15. So I can actually go through and rule out the ones that were not divisible by 3. let's see, 17 there. And just check the one that was divisible by 3. So anything divisible by 9 is going to be divisible by 3, but the opposite's not true. Just because it's divisible by 3 doesn't mean it's divisible by 9. So we said, actually we did say 3 worked for here, so let's check this out. 3 plus 2 is 5, and then 5 plus 4 is 9, 9 plus 6 is 15, but 9 still doesn't work for that one right there. So none of these will work for 9. So if you want to generate a number that could be divisible by 9, you could say, oh, just whatever comes to my head, I'm going to say 981. And let's check to see if that's divisible by 9. 1 plus 8 is 9. 9 plus 9 is 18. So since 9 goes into 18, I know that 9 will go into 981. The last one we have left is 11. So 11 is kind of weird like 7. It says subtract the last digit from the number formed by the remaining digits. If the new number is divisible by 11, the original number is divisible by 11. So just like with 7, I'm going to start with these smaller numbers first, and let's go through what that means. With 7, we would cross off the 4, double it, and subtract, and get, in that case, 7, so we knew 7 would be divided. We're kind of doing the same thing here, but we're just not going to double the number. So we're crossing off the 4, and then just subtracting 4 from it. So 15 divided by, can't talk right now, 15 minus 4 is 11. 11 will go into 11, so I know that that number is divisible by 11. If I take this 1, cross it off, subtract it from 16, I get 15. 11 will not go into 15, so we're going to cross off that 11. Take the 0, subtract it from 187, I get 187. Don't know off the top of my head if 187 is divisible by 11, so let's keep going. Cross off the 7, subtract it right here, and I do get an 11, which once again 11 divides into 11, so that will work. And then for the 476, cross off the 6, subtract it, I get 41. 11 will not divide 41, so let's knock it out. And let's go back up. Let's see. For these larger ones, take the 5 and subtract it, you get 319. Take the 9 and subtract it, you're going to get 22. 11 will divide into 22, so 3,245 should be divisible by 11. And since it's divisible by 11, I doubt this will be because it's only 1 away, but we'll go ahead and go through the motion here. If you cross off the 6 and subtract it, you get 318. Cross off the 8, subtract it, and this time you're going to get 23, which is not divisible by 11. So there are your divisibility rules. Like I said, I told you the most common ones I used, I'll sum them up again, is 2, 3, 6, 5, and 10. I never use 4 and 11, to be honest. I really don't use 8 or 9 either. You get 4 every once in a while, but they're out there, so I thought it was kind of cool to kind of show you them. Sometimes students really like, to see all of them and try them all out. Now, we finished off with 11 and divisibility rules about 11. I'd like to show you one more trick, not so much with divisibility rules, but with multiplying 11. So let's take a look, if I can get this off the screen, at a trick with multiplying by 11 that I use a lot. So let's take any 2-digit number you can do this with. Let's look at 54. And this is just all mental math here. I want to do in my head 54 times 11. So the trick with timesing by 11 is to add up the 2 digits you see here. So I'm going to rewrite this number 5, 4, some space in between, and 5 plus 4 is 9. So 11 times 54 is 594. And let's do another one. Let's say we've got 25 times 11. Once again, rewrite 25 with some space in between. 2 plus 5 is 7. Put the 7 in the middle, and you get 25 times 11 is 275. Now, sometimes the sum of these two digits is bigger than 10. So if you're working out these problems in your head, you have to do a little trick here. Let's say we had, let's do 66 times 11. And so 6 plus 6 is 12. So if I'm writing out the 66 with some space in between, I'm going to take the 2 and put it in the middle, but then I got to carry the 1 over right here and add. So it's going to be 726. So that's just a trick for timesing by 11. You add up the digits and put the sum in the middle between the two digits. I don't know. I'd say teaching math, I come up with it all the time, but even in everyday life, every once in a while, I'll times something by 11. It just makes it a little bit faster, and it's kind of fun to show people. So I thought that I would include that in this video. Well, hope you enjoyed the divisibility rules. Make sure that you look those over before the next quiz, and thanks for watching.